What we're going to do now is sit down and look at each different type of reticle and learn how to maximize the use of each one of them. First off, we're going to go to a duplex reticle, probably the same reticle that you started out shooting with when you was young. All right, looks something just like this, straight line crosshair, heavy duplex up top and on the sides. All right, now traditionally what we used to do is just zero the crosshairs either at 100 meters, 100 yards, or we'd zero the gun to where it was actually impacting a couple inches high, which would actually give us some kind of a max point blank benefit and would allow us to shoot at targets, 2, maybe 300 meters with a little bit of holdover when we got up to 300 and 400. All right. If you look at the reticle though, we can actually take and turn this reticle into a ballistic reticle. All right. If you actually zero the weapon system here, you can actually now, once you know what this measurement is, all right, there's several different ways to find that measurement. If you have another type of reticle like a mill dot reticle where you can actually line this up now and actually mill the difference from the duplex to the crosshair or all the way from one duplex to the other, then we have a unit of measure. Or you could even take a tape measure out there and figure out exactly what that would actually mean in mils. But once you zero here, let's just say that this is equivalent to 1 mil here and this is equivalent to 1 mil here. All right, what is a 1 mil hold? All right, for the weapon systems that we've been utilizing, a 1 mil hold would be somewhere around 254 meters. All right, so that puts our crosshair at 254. All right, so now what is a 2 mil hold? 2 mil hold is going to be somewhere around 360. So our bottom duplex is now 360. All right, so now instead of just having a crosshair and being zeroed on the crosshair, maybe a couple inches high where we can reach out, but now we're having to fudge. Long range precision is nothing about fudging. We're not trying to guess. We're trying to do something very accurately. So even with a old school reticle, just an old school duplex reticle, we can zero our crosshair here, be zeroed at 254 meters, and then be somewhere around 360 meters out depending on your muzzle velocity. So again, it helps to have the actual PDAs you can run through a ballistic program. And there's a lot of different ones you can actually utilize. Now the problem that you're going to run into is, let's say this is a 3 to 9 power scope. All right, once you have a 3 to 9 and you're running this at full power when you zero the weapon system, when you back that power off, everything's going to start changing. The one thing that doesn't change is your 254 meter zero. That stays constant. Your 100 meter zero up here isn't 100 meters anymore. So if you actually back it out to half power, and what you have to understand, half power isn't necessarily half power on what's marked on your scope. So if you take a 3 to 9 and actually turn it back to 4.5, you would assume that's half power. But you actually need to check it. What you need to do initially is mark top duplex here, bottom duplex here, and then take and turn your scope down until your crosshair is here and the bottom duplex is here. All right, this would actually tell you that now you're exactly half power on that scope. No matter what it says on the ring, this is half power now. So once you get to that, this now becomes your 100 meter zero. Your 254 actually stays the same at all times. But what does that do? Once we're at half power, this is equivalent to a mil, this is equivalent to a mil, now this is equivalent to 2. Make sense? All right, so now we're 1 mil down from our zero here at 254, but now we have 2 mils worth of use past that. So now our bottom duplex is really equivalent now to 3 mils. All right, so a 3 mil hold for your weapon system is going to be somewhere real close to 435 meters. All right, so now when we actually change, we'll move this over here to full power, all right, at 360. But when we are at half power, this here turns to 435. All right, so again, by manipulating the power ring on our magnification, we can actually very accurately turn a standard duplex reticle into something that's more useful, and you can actually reach out to range instead of going, I don't know, I held a foot over his back, that kind of stuff. So now we can actually utilize this, and you can continue to back down your power ring. All right, so as you do that, you can work further down, and all these numbers will change. But again, you can go out and shoot it, but it's much faster. Once you know what each line represents in mils, it's pretty fast to run it through a ballistic computer. If you know your muzzle velocity and your ballistic coefficient, your density altitude, you can actually run this through a ballistic computer or ballistic solver and actually have real precise holes all the way out to distance. Yes?
Got a question for you, Todd. If you back it off a little bit more because you're trying to work on work on getting a little bit further with your scope. Would your center cross here, no matter what, always stay at 254? It's just that you pick up more mils on the bottom. Is that what's happening here?
Yeah, absolutely. And really, basically we're zeroing here, you know, at 100 meters, but really we're zeroing at 100 meters for 254 meters is what we're doing. That zero is going to stay constant. As you run through your power ring, it's not going to change. All right, so this is old school stuff. This is what we used to utilize, and it's still a really good tool today. All right, now we've stepped up into mil dot reticles. Again, we have the heavy duplex, and the heavy duplex at, you know, at low light actually helps us sometimes see exactly what we're aiming at. The crosshairs, you know, if you're not utilizing illuminated reticles, a lot of times the crosshairs kind of get to where they get washed out and we can't see them. So the heavy duplexes really kind of help us pick up what we're aiming at the time when there's no light. All right, same thing with this. What I decided to do, instead of using a lot of max point blank like we did in the past, or running 500 meter hold over, hold under drills, what we ended up doing was actually zeroing here at 100 meters. All right, if you're working with a mil type turret, you can actually dial 5 mils up and put your 100 meter zero up here at the top duplex. All right, what this gives us, if you're working with a TMA scope, it's 17.2 minutes of angle equals the 5 mils. So if you're running either one, you're going to have to dial. If you're dealing with minutes of angle, you may only have 17 minutes is all you can dial. If you're in a quarter minute, you can dial 17.25. All right, but that gives us the same thing to where we're zeroed up here at the top. Now what this does, instead of doing like a 500 meter hold over, hold under drill, all right, or having a 300 meter zero on your gun and you're actually, you know, up in the top portion with your crosshairs for 100 meter, not your crosshair, but your actual hold. This allows us not to have to do math because that's what it's all made for. So basically what we call this is a poor man's horse. The poor man's horse allows you now, if I'm looking at a target and I say it's 305 meters, I know my mil hole's 1.5, I'm gonna put it right here. It's 1.5 mils down from the top. I know if I'm gonna shoot 400 meters, it's 2.4. So I'm gonna hold here. This would be 305, this would be 400. All right, if I know my holes for 600 is 5 mils, this equals 600. All right, so right now, very quickly, if I already have my dope sheet in my scope cap cover on the side of my gun, or I've memorized my holes every 100 meters out, very quickly, if I say, hey, I got a target at 780 meters, my hole's 8.2, all I have to do is look down and go to 8.2 and hold. So it's a very refined way to do this. Now, the problem that you're gonna run into is when you start getting out here on wind calls. All right, because holding out in space, and that's one of the huge benefits of the horse reticle, is that we always have a refined aiming reference point with the horse reticle. When you're holding out here in space, for one, it's hard to actually know exactly how much you're holding out. The other problem is when you actually think you're holding here and your bullet impacts here, you break that shot, you fall back down under recoil. The next thing you're gonna see is, all right, I see the puff of smoke or I missed my target, now where do I make my adjustment? You don't have any good measurement to go off of. It's not very quick. So a lot of times we have the guys actually go ahead and dial their wind if the wind's blowing like it does out here. So usually, I never tell the guys to ever dial wind, all right? We always hold for wind because things change. In a tactical environment, you may have a mover and you're holding, you know, two mils for a 4 mile an hour mover or 2.2, and you also have wind. So you're holding for both of them, but if that target actually turns around and moves the other way, now you have to start taking it off, and if you've actually dialed it on, now you're reaching up there and jerking stuff off and it's slow, and if the target's moving left and right, you know, it's kind of ridiculous to be dialing. For right now, we're just doing pure holes. This is the only time I actually tell guys go ahead and dial for wind is when we're actually using a poor man's horse like this. It's still a mil-based system, all right? So we can still use it when we're doing mil relation formulas to figure out how far away the target is. You can actually take the size of the target. If the target's 12 inches, divide it by what you mill it. If you mill the target at 0.8 mils from here to about here, if the target mills that size, the target's 381 meters away, all right? So you can utilize that by going 12 divided by 0.8 mils, all right? Once you do that, times 25.4 will give you 381. Now, if you're working in yards, you'd times 27.778, all right? So you can still utilize this the same way it was meant to be utilized. This is just a more refined method of utilizing a standard duplex. All we did is start adding in dots all the way through. All right. Now, once we went from this, a lot of guys started
Quick
going.
question for you, Todd.
Yep, go
Before
ahead.
we take that down. How do you find the system works out with using a more traditional mill dot system like the old oval-shaped USMC mill dots?
You know, I really didn't like the oval. They were 0.25 tall. You know, this is actually pretty good because you can actually take and refine it a little bit. All right, we'll make them a little bit larger. In some of the better systems, mill dots, there's a lot of different types of mill dots. Some have half mil subtension marks like this, all right? And then once you get out here, all right, some reticles actually look like this where there's 0.2 subtensions, all right? This is on left, right, top, and bottom, all right? So again, it's a good way to actually mill a target out. Anytime it is subtended more, what you're going to find is you can actually more accurately mill that target. Instead of looking in here and going, I don't know, the target's from here to here. All right, well, that's a little over a half. It may be 0.6, maybe 0.65. I don't think it's 0.7 yet, but we're guessing. We're trying to extrapolate, and that's the problem right now. So when we actually changed the reticles and we gave them half mil marks, all right, it made it much easier to actually guess and actually kind of figure out what the mills were. So if that target was milling from here all the way to there, now it's a little bit easier to see. That's probably closer to 0.7 right there. All right, so our eyes can break it up a little bit easier, all right? But as we go through and we start talking about the horse reticle in a minute, you're gonna see it's real easy to refine your milling to where you can very accurately get a range estimation. All right, the next reticle that we really kind of got into for a while, all right, was basically just a ballistic reticle. On ballistic reticles, you start out and you have 200 meter hold here, 300 here, a little bit further down, you go 4, 5, 6, 7, 8, and so on. Now, the thing about ballistic reticles, if you actually work with a ballistic reticle and it's made for your weapon system, your BC, it's kind of like a bullet drop compensator on your turret. You'd auto 200 for 2. All right, so you'd put the 2 for 200, 5 for 500. All right, they both have the same problem. The problem is this is set up, ballistic reticles and ballistic drop compensated turrets are all set up for one density altitude, one muzzle velocity, one BC. Unless you're hand loading and staying in your own environment and not changing bullets, if you don't, that's fine. It's a very accurate system. And if you're out here, you know, shooting in West Texas and it's using the same reticle and you're not going up to 8,000 foot hunting elk or something, this reticle works. But the problem with this reticle, the equivalent hold for this right here for 800 is 8.5 on the classroom gun that we've been running. All right, now if you jump up to 8,000 foot, your hold for 800 meters is really 7.5. All right, so this dot's gonna miss by a mil, all right, at that distance. You're looking at 26 inches for a miss. All right, so ballistic reticles really quit working after about 400. Now at 400 meters, you're only probably a half a minute off or so. All right, so it's still a good reticle out, you know, if you're hunting and you're not gonna take a shot past 400, that's where your limits are, that's what you set for yourself. Ballistic reticle is a good reticle. There's nothing wrong with the ballistic reticle. But after 400, you're gonna start seeing that separation. You know, last year we came in here and we was shooting training and I jumped up and went up to Colorado and shot an elk with my buddy. He borrowed my gun and he took a shot at an elk at 1,153 meters. He hit him with the first shot. We zeroed the gun here, trued it here, changed our atmospherics, went up there and hit the target. If we was using a ballistic reticle, it wouldn't have been even anywhere close, you know, even with the 338. So what you gotta understand is ballistic reticles, where they work and where they quit working. All right, so from 400 meters and down, not so much as you change altitude, all right? And that's another thing, most reticles are kind of set up at a average density altitude. You don't want to set one up for sea level and you don't want to set it up for 8,000 foot. They set it up in the middle to kind of cut their air in half both ways as they go up and down. The environment that some of our guys hunt in and the environment that our military boys fight in, you know, whether it's in Afghanistan or high up in other places, you can't utilize a ballistic reticle. It's not a system that will actually work.
Hey Todd, I'm gonna hold you for a second. I guess also you're not just talking about density altitude, but if you change that gun or that ammo or any other facet, that thing's getting affected at that point. I mean, that's just, you're just covering right now. If you went from, say, you know, Florida to up in the mountains, you're going to be affected. That same gun, same bullet, same hand load, same everything. But if you changed it around at that point, you're...
Oh, absolutely. What you're going to see is, you could actually take a standard mill dot reticle and put it on your 338, and you could pass it off and hand it to Mike and say, hey, try this on your M4, and he's good to go. It's a good system. It'll continue to work. But you take a ballistic reticle and your gun fell off this truck right now. Now you have to find another 308 ballistic reticle shooting the same ammo. You can say, hey, let me borrow that 300 Win Mag, let me take the scope off it and put it on this gun. It won't work, all right? So it's a huge point. A lot of times, we like the capability to swap scopes from one system to another. I used to have people tell me all the time, man, I can't afford a Smith & Bender scope. They're kind of pricey. And I go, well, how many rifles do you have, hunting rifles? And they go, oh, I've got 6 or 7, in the house right now. And I said, how many scopes you got on them? They go, 6 or 7. And I go, okay, what'd you spend on your scopes? $400 to $800? And they go, yeah, I've got one cost $1,400. I said, what if you sold all your scopes, bought the best glass made to man right now, and then put it on a ring that you could actually take it off, move it from one weapon system to the other? Now you're shooting the best glass made, all right, and enjoying the full capability of your weapon system. And you try to tell people all the time, they'll go out and they'll spend $3,000 on a rifle and put a $400 scope on it. If you're spending $3,000 on a rifle, it's really kind of smart to go ahead and spend $3,000 on a piece of glass, all right? The glass is actually more important than the gun is. Most weapon systems today, you can buy some really nice Tikka rifles, hunting rifles, and they're not very expensive at all. You can get $500, $600 rifles. They're very accurate. They're minute of angle rifles. Put a $1,000 piece of glass and you're going to maximize the benefits of accuracy that you're going to get out of that weapon system. But if you take a $3,000 rifle, custom made by Tactical or Surgeon or any one of the great, gunsmiths out there today, and they're making good weapon systems, and put a sorry piece of glass on it, you still got a 2-minute of angle gun as far as the effects that you're getting on target, because it just changes. If you're working with a really good piece of glass, you're going to maximize and get the benefits of whatever that weapon's capable of. And most of the guns are very capable that are made today for the hunting market, and as well as the tactical side. Very accurate, but the big deal is we really need a good piece of glass. But let me show you something else that we was talking about a little bit earlier, all right, when we was going through second focal plane. All right, back to a mill dot reticle. If you're dealing with second focal plane reticles, in second focal plane, a good way for you to know if yours is second focal plane, when you look through it, all right, you've got your reticle and you've got your target. If you decrease your magnification, if your target shrinks in size but your reticle stays the same size, that's second focal plane. The problem with that is you can only mill at max power really effectively. But there's other things that we can do with it, all right? So if I go ahead and I actually zero here, and I turn down to half power, and again, you have to utilize the same thing because not all dials actually equal what they say they do. All right, so if we cut it down to half power, each one of these mill dots is now worth 2 mils. All right, so if I'm wanting to extend my range and I do the poor man's horse and I zero up here for 100 meters or 100 yards, all right, now this is zeroed at 5 mils, or the equivalent of 5 mils for range for whatever weapon system I'm working with, and this is equal to 10 mils. All right, same thing as we talked about a while ago. If I cut it down to half power, this now is 100 meters, all right? And then, what do we have here? This is still 5 mils, but this is worth 10 mils now. So I have a total of 15 mils that I can actually utilize. Again, we can continue to decrease, all right? So if you have a, let's say a 4 to 14 power scope, 7 power would be half power, right? But what if you was able to come all the way down? What if you divided 3 into 14? That would tell you what each mill dot's worth, all right? If you were down at 6 power, 6 into 14, that tells you what each mill dot is worth in mils, all right? So you can actually really start to push out your range with the current systems that you have right now. You don't have to run out and go buy, a Smith & Bender scope with a Horus reticle. This is good knowledge. It's a good way to utilize it because you never know what kind of weapon system or a scope or reticle that you're going to be running.
I think that's an interesting point you bring up because in most instruction sets, people say you can only mill at full power. And if you really know that magnification ring and how to set that, effectively what you're saying is you can effectively mill a target at half and possibly quarter power.
Yeah, you can. The only real problem with doing that, though, is for one, the target gets smaller.
Sure.
All right. And as that target gets smaller in a second focal plane scope, it's going to be harder to mill. When you're doing UKD shoots or unknown distance targets, the problem is that target, as small as the targets are that we shoot at, when you start backing out that magnification ring and you don't have much power to work with, it's very hard to mill that target at that size. But the biggest problem is the calibration of your actual dial, knowing exactly where half power is. So again, biggest points here are calibrating our reticles, making sure that everything is matching up with the dials. The other deal is, guys, when you're dialing turrets, you really need to make sure that you've actually calibrated and made sure that what that turret is turning is actually happening inside the scope, all right? So as you're turning that turret, you may dial 5 mils, but you may not be effectively getting 5 mils out of that turret. It's a man-made mechanical object. Sometimes they're not that great. And I've seen a lot of them that you dial 5, you get 4.5, especially when we start shooting out to the ranges, you know, that we're looking at. Now that was a extreme, is being a half mil off at 5 mils. But when you dial 20 mils, it's not uncommon to only have 19.5 actually being dialed onto that scope, or having 20.3 or something like that actually on the scope at that time. So another way, like we talked about the cat's target, it's a real cheap piece of paper, and you can actually, you know, use a ruler or something, a yardstick, and actually draw it off. You know, we talked about 100 meters or 100 yards. If you go 100 meters, you need to have 39.3 inches, you know, at 100 meters to have 10 mils, where you at 36 inches is what you need for 100 yards. All right, so if you take a ruler and you mark it off and you're exactly 100 yards, and you really have to be exact on that, but it'll equal 10 mils, and you can start calibrating and figuring out what your dial is, how much, you know, turrets that you actually have as far as how effective they are. And we'll actually show by shooting the cat's target that when we shoot at the little box on the bottom and then we actually dial 10 mils and shoot and it actually hits on the 10 mil line, or dial to 20 and it hits on the 20 mil line. You know, I tell the guys it's something like the old commercial used to say, you know, moose hunt, $7,000, flight to Alaska, you know, 600, you know, guide service, this, that, taxidermy, you know, a calibrated scope is priceless. If you don't know what you're getting out of it, you know, I was shooting in a competition one time and I wasn't real used to that scope. I was actually shooting a horse reticle in that manufactured scope, but the turret wasn't actually correct. So at 4 o'clock in the morning when we're shooting movers in this competition, it was real dimly lighted mover, was 500 meters back. I dialed up 3.5 mils, my hold for 500 meters, because I didn't want it to be in that bracket. I was real new to using the system. So I dialed 3.5 and missed a whole bunch of targets that night, all right? And couldn't understand why until I took my scope the next day and checked it, and 3.5 mils wasn't equivalent to 3.5 mils. But that's experience, you know. Tried something, figured out from that point on, if you're ever gonna dial, you need to know exactly what that dial means on your scope. So if you dial 5 mils, know that it's 4.8, or know that it's 5.3, or know that it's 5 mils exactly. A lot of the scopes that are made today, good quality scopes, usually are pretty close, all right? But that doesn't mean all of them are. So it's something that we actually need to check, all right? So now, the next reticle that we're actually gonna go into is a horse reticle. All right, the horse reticle is basically subtended 0.2 mils all the way down left and right, all right? So, and it also, when I say left and right, it gives us wind as well. So if you look at what we're looking at here, you'll have lines. It's a gridded reticle, all right? Has 1 mil marks all the way up, and then it's subtended at 0.2 mils all the way across. Now initially, if you're like me, first time I looked at it, I said, oh man, that's too busy. I don't like it, all right? After the second day, I said, all right, I got it. I can see there's some major benefits here. I'm not dialing, I'm not leaving the wrong dope on, you know, I'm always just doing holes. I can see if I can see my impact where I missed, very quickly I can do a second shot correction. I can mill much better utilizing this than the standard mill dots that I've used in the past. And so I started to get around it a little bit, but it was one of those things that I really didn't like it. I still thought it was a little bit too busy for me. The more I shot it, by day 3 and 4, when I woke up on morning 4, I was already trying to figure out a way to, you know, get a good guy price on one, because I was already sold. Once you've actually utilized it, what you're gonna see is you actually look through the lines and find the target. All you utilize the lines for is a reference point as far as an aiming point to utilize for aiming. So when you actually look at the reticle, at first your eyes are focusing on the reticle. But once you start using it, you realize very quickly your eyes are focusing on the target, and then you just find the actual hold that you need to hold on the target, and that's the only part of the reticle that you actually see. A lot of people say, yeah, it's too busy, I can't use it for observation. There's many guys that do, all right? So that's already been debunked. I've heard you can't shoot movers, you can't shoot snaps, you can't, get lost in the veg, and none of it's valid. We've actually tried it. We can actually shoot anything that we want to shoot as far as reticles. If my son goes down range in a couple of years, this is the reticle that I want him to have because I know the benefits of it. I know what it'll do for him. You need about 4 days on the horse reticle to really get wrapped around it. I have a lot of guys that actually try it and then they put it up and they go, oh, it's too busy, I really didn't understand it. It's really just another meal-based system is all it is. There's nothing wazoo to it. You just don't have to dial anymore.
Well, that's the biggest problem with our society, specifically when we're talking military and when you get into special types of groups of people, A-type personalities, obviously. That's what we do. We look at it and we're like, it's too busy. We shoot it a couple times, like, nah, I'm used to what I'm used to. I'm not that comfort zone. And that comfort zone should be an alarm in our heads that go, hey, wake up, I need to think outside the box here. And that's what I've been doing, looking through this system now. Every time I look through it, I find if I look through it consistently and keep tracking that thing, it just gets easier and easier and easier. And it's just like anything else we do in life. Driving a vehicle, the first time you jumped in a truck when you were 15, 16 years old, were you comfortable? No, you were like, oh my God, you're trying to look for every little line and not hit any oncoming traffic, but now you're drinking coffee, texting, and driving with your knee at the same time. So it's like anything else, it'll come.
First time in a helicopter, you're kind of hanging on, don't know exactly what's going to happen. Is that pilot any good? Then the next time you're hanging out the side shooting at coyotes, it's that progression, and it's the same deal, it's comfort zone. So initially when we look at it, because we may not understand it, we don't want to give it a try. Because it's like, hey, I don't understand it, so I'm not going to be the guru on this anymore. But once you look at it, it's just a meal-based system. It's just refined so that now we can meal better. We have more reference, as far as aiming points. And there's nothing different. There's nothing wazoo. It's just a very basic reticle once you actually apply it.
It's common sense.
Absolutely. All right, guys, so as you can see, there's a lot of different reticles out there that we can utilize. The biggest point is don't get locked in that old school method. Expand your horizons, get out of your comfort zones, learn how to use the one that you have better, and look at what others have to offer. All right, so play with the PDA, look at the math, go through it, none of it's hard. Rewind the DVD 2 or 3 times and you'll figure this out really easy. This isn't rocket science, all right? So it's just very simple math as you go through it. Back to the basics, it's just the fundamentals. The more you understand the principles that apply in the math when you're looking at the reticles, the simpler it all gets.